Today's lesson is about the present value of an amount, which is part of one of the four kinds of cash flows for the time value of money. In today's lesson, you have money out here in the future. In this case, it's 5 periods out in the future. And the question is, what is that money worth today, which is at time 0, looks like 5 years back to the present. What's it worth today in today's dollars? Well, we're going to use this formula, which is part of, includes the present value of an amount table, to figure this out. So here's our first problem. How much would you have to invest on February the 1st, 2006 in order to receive $1,000 on February the 1st, 2009 if the annual interest rate is 12%? So, first thing you want to ask is the unknown in the present or is it in the future? Well, the unknown is in the present, which is February the 1st, 2006. We know the future amount, which is $1,000. So, is the lump sum the unknown, or is it a series of equal payments? Well, it's a lump sum that's unknown. So, it's in the present and it's a lump sum, and so we're going to use, looks like of these four tables, we're going to use table 1, or the amount for the present value of an amount. So we're going to plug in the things we know, and this table will be based on, the formula will be based on 12% for 3 periods. So $1,000 times a table value in the present value of an amount table based on 12% for 3 periods, that gives you a table value of 0.7121. And if you multiply this table value times $1,000, what you end up with is $712. So I could say that if I had $1,000 3 years out in the future and I want to know what that's worth today, that is 3 years back, going back 3 years at an interest rate of 12%, that as I'm missing out on that 12% every year for 3 years, in today's dollars, that $1,000 is, if it's discounted back at 12%, is only worth $712. Let's go to another one. Or let's take a look and see how I computed this on this table. The first thing I did was I said I'm going to look at the present value of an amount table, and I'm going to look at 3 periods, and I'm going to look at 12%. And the table value that gives me the correct table value is, our table is going to be, forget all that, it's going to be 0.712 is the correct table value. And when I multiply that 712 times 1,000, I'll get that $1,000 right now is worth, 3 years out in the future at 12% interest, discounted back for 3 years, is worth now $712. Another way to look at that is to say I'm out here in the future and I got $1,000. And if I want to go backwards to see what that was worth 3 years ago, or back to the present time, and I had an interest rate when this was going on of 12%, then the $1,000 will be worth, one interest period from now back will be worth $893, and I go back another interest period and it's worth $797, and I go back to the present and it's only worth $712. So I'm going from some point in the future back to the present and asking the question, what's the money worth right now in today's dollars? Here's another example. How much would you have to put in the bank today at an annual interest rate of 12% for 4 years to accumulate a $6,000 down payment for a house? Now, that $6,000 down payment is going to be 4 years into the future. But I want to know what I have to put up right now and put it in the bank in order to get that $6,000. Well, is the unknown in the present or in the future? Well, I know the $6,000 is going to be 4 years from now, so that's the future. What I don't know is the present. And I'm also going to ask the question, is this a lump sum or a series of equal payments? Well, it's a lump sum that I'm trying to ask what it is. And so again, I'll be using table in this case 1, it's in my book, which is the present value of a single amount. And I'm going to plug in the pieces that I know on this little formula. And I know that the table is going to be based on 12% for 4 periods. And I know that the future amount is $6,000. So $6,000 times this table value, which is 0.6355, means that today's dollars, $6,000 discounted back for 4 years at 12%, is worth $3,813. Or I've got to put $3,813 in the bank today and keep it there for 4 years at a rate of 12% interest to get my house down payment, which will be $6,000. And I think that is the... No, we got one more. How much would we have to put in the bank today at an annual rate of 14% for 6 months to accumulate to $5,000? Now, this is a partial year situation. So if you looked at my other little videos, you know that if we're dealing with, in this case, half of a year, then you're going to use... if the annual rate is 14%, you're going to use 7% as your rate to use to look on a table. So the unknown in this case is in the present, and it's a lump sum, and we're going to use table, in this case, the present value of amount, or present value of a lump sum, table B1 in my book. We're going to plug in what we know, which in this case is a partial year. If the annual interest rate is required at 14%, then we want to put in a half a year because we've only had the money in for 6 months. So that's 7% for 1 period. That'll be the table value we'll look at, which is 0.9346 times the $5,000. And that means that if you expect to get $5,000 6 months from now, you'd have to put up $46.73 in the bank right now, keep it there for 6 months, and earn an annual interest rate of 14% or a 6-month interest rate of 7%, which would be $46.73. Now let's see, is that all of them? No, I've got another one here. How much would we have to put in the bank today at an annual rate of 15% for 40 years to accumulate $1 million? Here's the old $1 million question. Well, I want to ask the question, is the unknown in the present or in the future? Well, the unknown is what I had to put up today, which is the unknown, which is the present. And it's a lump sum. I'm putting in a lump sum amount, and I'm going to leave it there for 40 years, and hopefully it'll accumulate to $1 million at an interest rate of 15%. Is what I'm getting on my money. So which table are we going to use? We're going to use the present value of an amount table, which in my book is B1. Plug in what we know, which is 15% for 40 periods, and the future value is going to be $1 million, and the unknown is what we're looking for, which is the present value. So $1 million times this table value, 0.0037, means we'll have to put up today $3,700. If you put up $3,700 and left it there for 40 years and could get an interest rate for 15%, you'd have $1 million when all things cleared. And I think this is the end here. Yes. So we're finished.